Right, let's get this sun element done. And I'm going to use a similar setup that we used in the cloud element. So give that episode a watch if you haven't already, where I explain the whys and wherefores of what we're doing. And with that in mind, you can see that I've already set up a reference image and the sun element that contains our sun view so we can get straight down to business. It's a relatively simple one, so it shouldn't take too long. I'm actually going to deviate a little bit from the reference image here because it's our own icon. We can do whatever we want. So I'm just going to use that as a jumping off point. And this is going to be a size agnostic icon, as they all are, because all the elements inside are going to be based on the size of the frame. If you notice, we're not using a shape for this. So in order to make the components of this sun size agnostic, we need to use a geometry reader to control their sizes. So let's put that in now. Geometry reader. And I'm going to put a Z stack in. And the first thing I'm going to do is actually the rays of this particular sun, because ultimately they're going to be emerging from behind the sun. So I want to put them in the Z stack first. And that's easy because we've got 8 rays and we're going to use capsules to represent those rays. So let's put in a for each of 8 capsules. For each 0 up to 8 ray index in. Put a capsule in, it's going to be absolutely massive. Fill, color, yellow. And let's get the size a bit closer. I'm going to give this a frame based on the size of the geometry proxy, and PureSwiftUI has a lovely extension for this, allowing us to scale the actual size of the geometry proxy in both the X and the Y. Frame, geo, size scaled, and we can pass in a width scale and a height scale. So let's try 0.08 of the width and 0.2 of the height. Okay, that's looking pretty much how we want it, but as you can see, it's sprung up to the top left of the view. And it did that because we are inside a geometry reader. And if you put non-greedy views inside a geometry reader, they will by default go up to the top left of the view. Now, even though capsule is a greedy view, we've restricted its size. And because we've done that, we've got to make sure that the view containing it is a greedy view itself. So we can turn Z-Stack into a greedy view by giving it a greedy frame, just like that. I've done an episode on geometry readers where I go into a bit more detail about this. Now we need to offset this thing so it's in the right position. And we can do that by giving each capsule a Y offset, again, scaled to the size of the geometry proxy. Y offset, we're going to go negative because we want to go up. We're going to say geo, width scaled, it's square, so it could be height scaled as well, minus 0.4. And lo and behold, it's perfect. Yes, I might have done this before. And as you can see, my rays are a little bit longer than the original, and that's the way I like it, because remember, we're not trying to recreate this precisely. Now we need to rotate each ray 45 degrees, since we've got 8 of them, based on which index we're on. Rotate 45 degrees times the ray index. And now we should have our rays. There they are. And the last thing we do for our initial design is put in the middle circle. Circle. We'll give it the same fill color as this one. And then we're going to say that the frame is the width scaled times 0.45. There we are. That's good enough for our needs. And since we've got our shape, we don't need our reference image anymore. So I can go down here, get rid of that, get rid of our SF symbol there, and then indent these properly. There are 2 things left. First of all, whenever this sun is showing, I want these rays to be rotating. For me, it doesn't make sense for there to be a sun on screen if it's not animating. We're going to do that with a Boolean state variable called rotating rays. Rotating rays starts off as false, and when it appears, I want to say in an animation block with a linear animation with a duration of 8, we're going to repeat forever with an autoreverse of false. I'm going to say rotating rays is true. And now we have to give each ray an extra rotation based on whether or not the rays are rotating. And we can do that by modifying the for each view. Rotate if, lovely conditional here, are we rotating the rays? Then we want to rotate it 360 degrees. And at this point, if we resume, I should be able to play this. And we'll see our lovely rotating sun. Isn't it wonderful? The final piece to the puzzle is making the rays expand from the middle so they have a nice animation when it appears. I want that to be controlled externally, so I'm going to set up the support for that inside the sun view, but allow it to be controlled at the call site. So we're going to need a property, which is going to be a constant. Let showing rays, which is a Boolean. And now I'm going to change the Y offset to a conditional version of that Y offset to only offset the rays if we are showing them. So I go down here and say Y offset if showing rays, and then it will only offset them if showing rays is true. Before we resume, we need to make sure that we're passing in showing rays into the sun view. So I'm going to give our sun element the same property and make sure that we're passing it in. Showing rays is showing rays. And to test it out, in our harness down here, we can set up a state property to simulate that. And I've often been asked why I use a preview structure like this. And one of the reasons is that you can simulate proper state changes when doing that, because you're not dealing with static properties here. You're dealing with an actual property of a struct. So you can use the state property wrapper and it will work as expected. So I can say showing rays is false. We'll say on appear. We'll just do a default animation here and say showing rays is true. And lastly, we need to pass it in. Showing rays is showing rays. And then we can resume. And when I play this, you'll see the rays spring out from the middle. There they are. And in our element itself, we can just say the scale is equal to 0.7 or something like that. But we're going to deal with that when we come to combine these elements together to form our sunshine on a rainy day icon. In the next episode, we're going to be building animated rain, driven by transforms of the layout guides we use to define those raindrops. So join me for that. It's going to be brilliant. Don't forget to like the video, and if you don't want to miss the rest of this series, consider subscribing if you haven't already. If you have any questions, comments, or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.